Thank you all very much. Thank you, Andrea, for starting off this session. I couldn't ask for a better introduction. So my name is Noam Ross. I'm executive director of rOpenSci. rOpenSci is an organization that aims to foster a culture that values open, collaborative, and reproducible research using shared data and reusable methods. And we do that by building a technical infrastructure and a social infrastructure for the R ecosystem to enable that open science in a welcoming and diverse community. I'll be talking a little bit about community in this, but we will all have the privilege of hearing Shani talk about community. She is our world-class community manager and will be giving the keynote at the end of today. The focus of my talk is on the idea of package curation in communities and collections. It's something I've found in the past couple of years talking with a number of different groups that we have this pattern in the R ecosystem of package collections, curations, or universes that have come about that is not unique, but very strong in the R ecosystem. I have some hypotheses about why this is. The very low barrier to entry for package creation means people often create small interrelated tools. The culture driven from sort of the Unix one tool well means that people sort of create lots of packages that compose together in different ways. But this exists at many different scales. So there's sort of the whole repository scale. So groups like Bioconductor. Bioconductor is a CRAN scale repository of thousands of packages that are all designed to be installed together, that are worked and composed together in certain ways. Then you have looser collections like the work that rOpenSci does of doing peer review under common standards that are not necessarily sort of interoperable ones, and even broader, say that the Journal of Open Source Software curates a collection of peer reviews, right, of specific packages. And then from very early in the language, we had this concept of task views, which are collections of packages that do related things. Very few people do this, but there's a function to just install a whole task view together in the R ecosystem. And then you get to sort of smaller, more tightly integrated package curations like the Tidyverse, which is very well known, has a very strong common API approach to how one manages data. There are lots of other sort of specialties and DSLs. So for instance, for machine learning, you have the MLR ecosystem. For Bayesian statistics, there's all the stuff that is built around the Stan language and the Stan package and Bayesian analysis ecosystem. And then you get to domain-specific collections of tools. I work closely with a group called Epiverse and the R Epidemic Consortium that have collections of tools for outbreak analysis and epidemiological response. And other groups like NOAA has the fisheries management toolbox that they have collection of packages for fisheries assessment in a government context. And after 10 years of curating a collection of packages at rOpenSci, I found that, this is a challenge lots of groups have. You might have at the lab scale or the company scale or the industry-wide and field scale a collection of tools you want to manage together, such as in the R ecosystem. And what do we know about what's useful there? Well, I've sort of come down saying there are like 5 parameters you want to think about when you're managing a package ecosystem, which are your scope, your standards, your process, the commitments in those packages, and the community around them. And I think a really important thing is then in setting and evaluating these parameters, they are driven by the goals and the values of your organization. So what I'm going to do in the next 10 minutes or so is go through how we have thought of these components for the rOpenSci ecosystem, and then do a little compare and contrast with other systems with different scales and goals and models. So I told you a moment before about rOpenSci's values of collaboration, open science, and having a welcoming and inclusive community. We have specific goals when it comes to rOpenSci's software peer review. In the peer review process, we are interested in using it to build capacity of the developer community, so that's at the individual and community level, and driving the adoption of best practices and best software engineering practices in a community that's heavily self-taught software engineers with scientific backgrounds. And then we want to improve the quality, discovery, and sustainability of those R packages that are used for open science. So what does this mean for our scope, standards, process, commitment, and community? Well, for scope, rOpenSci started out primarily in the environmental sciences and primarily interested in the interchange of open scientific data. And so for many years, we had a relatively constrained scope around packages that managed the data lifecycle and the data lifecycle for scientific data. This has overlap with many different tasks out in the data analysis community, and we came up with sort of a focus on we are interested in specific applications within scientific fields and avoid generalist applications that are very, very broad data science projects that are likely handled at a different scale of community. So we focused on interfaces with scientific databases, interfaces with scientific repositories, things like topic-specific data validation, handling munging, and data type interfaces. Then at a certain point, due to really demand of our users, people were interested in the same review process for statistical packages. And we thought, how do we define what is in scope for statistical packages? And we ended up doing a big natural language processing exercise along with a bunch of expert reviews of going through all of the R conference abstracts, all the R journal abstracts, all the Journal of Statistical Software abstracts, and all the JSM meeting abstracts, and say, what are the topics in statistical computing that we're interested in that we can define scopes and standards around? And so in 2021, we started reviewing statistical packages, and this became part of our scope. And we decided we couldn't define statistics writ large and statistical algorithms, but we could come up with a bunch of relevant subtopics that we could define review standards, processes, and expertise around and recruit people who could do that type of work. And so this gave us a sort of broad scientific focus, but a less general one, and a focus on what we call the long tail of scientific computing. So how does this vary from other scopes? Well, so one project we work with a lot is the Journal of Open Source Software. Journal of Open Source Software has an even broader scope. Journal of Open Source Software applies to any computer language and essentially any non-trivial scientific application. This comes from a specific goal, which is improving the visibility of scientific software in the academic and publication sphere. So people can easily get their work, which is published in a software context, published in a scientific manuscript context. They aim to really lower the barriers to participation, and that drives that very wide scope. On the other hand, a group like Epiverse or Recon, which focus on tools for public health researchers to, not public health practitioners to do rapid response in outbreak scenarios, have a very specific set of applications. And they decide to include in that focus the sort of glue packages that might have general purpose, but are really important to integrate into a set of composable tools. So things that are not necessarily specific to outbreaks, but are date handling packages, are within their scope, because it's important to be part of that composable ecosystem. Standards are often what people jump to as sort of the most important thing for a collection. What is the common set of baseline requirements for a package? We place a very heavy emphasis on standards in documentation, on developer documentation, on things that improve maintainability of packages, because we are interested in that collaborative aspect that allows people to participate. So rOpenSci has a broad set of standards that are focused on transparent software engineering, along with a lot of other topics. And we tend to think of them as lagging standards in that they represent the best practices in the community, even if they're not super widely used, they're well established, and that there are tools and documentation to enable people to use them. So for instance, when we started requiring continuous integration, it was well after continuous integration was something that was available, after people had written R packages to ease the setup of continuous integration. And there was a lot of documentation. There was a chapter in the R packages book that made it easy for people to integrate. We wanted people to have access to these best practices. On the other hand, when we started working on statistical packages, our review really said there weren't adequate best standards out there that were commonly practiced. And we decided we needed to develop a set of leading edge standards, which were things that were not necessarily widely used or in the statistical fields, really well established, but would push the envelope. So we have a variety of standards regarding testing for statistical correctness, which are really not common out there. They're a high bar for people to meet. But our goal of that project was to push the standards of the community more rather than just get existing standards out there. And so that changed the way we designed that. You have whole other topics that we don't cover in other ecosystems. So for instance, Bioconductor or the Epiverse project have goals for interoperability of data. So both of that ecosystems have requirements that you use certain data classes for interchange of certain types of domain-specific information, be it genomic sequences, which have S4 classes in the bioconductor ecosystem, or line lists, which are a epidemiological sort of time series format for Epiverse. And then you have other requirements that are driven by other things entirely. So NOAA fisheries, but also some of the work the Pharmaverse is doing, the R validation hub. These are driven by regulatory requirements, which are really hard and define these standards. Process is the mechanism by which your scope and standards are enforced. Who is participating, how it is participated in. So for process, we developed a system that is very much driven by practices in scientific peer review as much as software engineering peer review, but also has components that really drive that sharing and community component. So our work is, unlike most scientific manuscripts, done entirely open. It's not double blind, it's double visible. Everyone knows who each other is. Review is done in public, so basically in GitHub issues of people having a conversation that's curated by an editor, but there's direct conversation between reviewers and authors. And it is very heavily driven by our approach to tone and non-adversarial constructive criticism within the system. We think this is really important because it means that people can learn from each other and learn from each other's reviews and not just the individual exchange, and also develop collaborations because reviewers and authors can learn about each other, and we have seen develop collaborations in the future because they have had that exchange. You can reach this point where reviewers just decide to pull request their feedback into the package rather than write a bunch of text, and that enables people to iterate rapidly and become a more supportive community in the process. This is a very labor-intensive process, the way we do it. So that process is also augmented by a whole lot of investment in automation. So packages are automatically checked and a whole bunch of diagnostic information provided to both the authors and reviewers upon submission. That means that everyone can understand whether things are up to snuff for review. People get feedback instantaneously. That reduces friction. We also have a chatbot that manages the process, and very much infused in the language of that chatbot is our approach to a friendly, welcoming interface and a non-adversarial community. So our rOpenSci review bot is a very friendly guy. This is a big investment. Not all organizations can do it, and it's not necessarily the goal. So for someone like the Journal of Open Source Software, they're really aiming to lower barriers. It's much less intense review process. So they don't demand as much time and effort from their reviewers, and they really aim to constrain that exchange, right? It's just a few back and forths to make sure that things meet minimal requirements. On the other hand, someone like Recon or Epiverse have really high standards because of their partnerships with public health institutes and ministries, and therefore they don't actually have an open external review. Things are really done by an internal set of experts, right? Because there are epidemiological requirements, methodological requirements they need to meet that can't necessarily be farmed out more broadly. Probably the most challenging thing in all of this is what I call it commitment, but is thinking about the role of authors, reviewers, editors, and hosting organizations beyond the point of inclusion in some sort of package collection. This is something we didn't think about initially and have made halting step towards at rOpenSci. For a while, we had a commitment that the organization was always the maintainer of last resort, which left feasibility as we had hundreds and hundreds of packages in our purview. So one thing we've implemented recently is we simply ask the authors to make statements about their expectations of the package lifecycle. Where is this in development at time of review? Is this your dissertation? It's done, it's submitted. You've got another job and you want it out there. Is this the start of a new project that is going ahead? Is it somewhere in the middle? What are the expectations? And so we ask for these life cycle statements. And that is a partial commitment component that sort of really just gets people thinking about what their own commitment is within the context. It's not binding, but it helps initiate that process. But part of that does include what our sort of organizational commitments are, which is to provide that sort of maintainer community. So if people are continuing to update their work, we have a lot of ongoing touch points to help support package maintainers and initiate maintainer succession. So people might roll off of a package and be looking for new maintainers, be looking for new contributors, be looking for help within theirs. And through sort of both push and pull mechanisms, when we call for new maintainers, when we push out surveys to ask people if they need new maintainers, we don't provide necessarily a guarantee of long-term sustainability, but a commitment to help support people who are participants in that curated collection. That's one of several models. Those models are often very implicit. So at a scale of a CRAN or a bioconductor, there are specific requirements. So bioconductor has updates twice a year, and one updates their packages for cross-compatibility. CRAN has continuous cross-compatibility packages. And there's an implicit requirement to participate by staying updated. And while you can always be archived or removed, there's sort of like a degree of like community practice of keeping it up for some period of time. It's not very well defined. JOS does the opposite in that low barrier. It's a timestamp. You're marked once. You got published. It's done. There are no requirements beyond that point. We know when, at what stage of version of the package something was approved, which is something that we're doing more at rOpenSci of linking versions in that. And then there are places that have very high requirements. So we're still working this out with Recon and Epiverse, but they're also, again, tightly linked to training programs at public health ministries. And for that, you need a real guarantee that these are going to be available for these people that you are training in the system that is associated. And so we're thinking about essentially a rule that you need multiple maintainers with a guarantee of multiple years in order to enter the system. So the other thing I want to talk about is community. I'm glad we already had a bunch of community. We'll have a whole bunch of other community. But I want to make a couple of observations about what is helpful and essential in the role of community when you're doing this type of curation. So community underlies your capacity to do any of the tools, to have elaborate process, to have robust standards. To do that, you need a certain capacity within a community, but that does help solve certain problems. So people who are involved in academic publication know how much, especially over the past decade, that whole system has been strained in, say, the ability to get reviewers, the ability to get things through the system. And I'd argue that part of that is a lack of investment in the community relative to the actual throughput of the system. So we've been very lucky to really not have that much of those problems of trying to 15 people before you get a reviewer for a package. But the reason for that is that pool of people we have out there, we have invested in common effort and support and values and trust, which means that a lot of people who are out there who are enthusiastic about the process, whereas you might have a challenge elsewhere that you might not have a strong connection to the journal you connect with. You might have ambivalence of differences in values between you and the for-profit publisher that's publishing those journals that changes your relationship and your ability to invest your time. So that's been a great help of making sure that we have people in the system who can participate in a review, can help with that curation, and people who stay on for maintaining their packages. Then when we think about that sustainability element, another very hard problem in this type of ecosystem, how do you keep packages that are especially part of niche scientific applications without huge, broad contributor bases alive for their uses in their fields? Then community is another point of investment. So we try to do that package succession, and that package succession is investment of weeks or months of trying to find the right people. But at the community scale, that is an investment of years or decades, really, of doing the training, the mentorship programs, right? So the community support, so that we have built the pipeline of open source leaders who have expertise, right, and have the ability to work in the system, so that there are new people to take on the mantle of the new packages over time. And so that means going all the way back to the beginning of that mentorship community investment when you're thinking about your capacity to do commitment in your curation. And then sort of the final note that I think is really important is that the capacity of this community is built on trust and shared values. And an absolute and essential value for us in that is diversity, equity, inclusion, and accessibility. And that is what enables these things to happen, because it's what enables us to have a global trusted community that is willing to invest because of those common values. So that gives us the capacity to do it. And then simultaneously, it's why we do it, because we work for open science and open source. And the fundamental value of that is that the benefits of these tools are accessible to everyone. And so at a time when those values are under attack, we believe we need to sort of double down on it, because without those things, we'd have neither the how nor the why we're able to do this work. So that's it. Thank you very much.